Welcome to the first regular episode of Learn Software Architecture channel. If you joined us last week, there was a live interview with Radek Maziarka where we were talking about tech leadership. And as I mentioned there, this channel will always have 4 episodes per month, where one episode will be a live session with me where you can ask a lot of different questions and I will try to answer it. Then there will be a live interview with one of IT gurus with a topic around software architecture, tech leadership, software engineering and more. And another 2 episodes which will be irregular ones. And in each of these episodes I will focus on one concrete topic from software architecture. And this episode from today starts a series of 5 episodes for the topic of evolutionary architecture. When we start our professional careers, usually we face similar path in the beginning. We join as a junior developer or apprenticeship, or we join some internship in a company, and then we start to code whatever we have to code. So our life looks like code, and then more code. At some point, as we are more experienced devs, we start thinking about areas which are laying around the code. So how our infrastructure works, how the deployment strategy is handled, how solution architecture look like, and many more. We start to attend conferences, meetups, discuss with our colleagues about the ways how we handle the stuff in our application. And we hear there about all these things like microservices, cache, event streaming, event sourcing, CQRS, and many more. At some point, we decide to just apply all this stuff into our applications. Been there, done that. And it didn't end well. And here our problems begin. You might ask why and what kind of problems. Our application gets more and more complex. New team members have a high entry threshold to just get into our project. It can take them 3 to 6 months to code regularly and be involved regularly in our software, just as other guys in a team. Another thing is that finding bug might be extremely painful and a long-running process because we really don't know where it happens, especially when we are lacking of proper monitoring. My goal here is that you don't do the same mistakes as I did in the past, or at least you can minimize the risk of occurrence of these issues. At some point in my career, I started questioning myself. Hey man, why did you choose microservices here? Why did you decide for event streaming? Why did you introduce cache? And so on. Do I really need clean architecture in this project? Do I need it for all the modules that I have? Do I need to apply hexagonal one? Onion, what is the difference between hexagonal, onion and clean architecture? And so on. So there were a lot of questions coming to my head. And I started diving deep into the topic. I started reading a lot of books. I went to many conferences, meetup groups. I discussed it with speakers and then with my other colleagues who were experienced architects. And they told me something very wise. In the beginning of career, we are doing a really simple code. So our code is really simple and then the complexity of it grows. We introduce all the abstractions, components and so on. And at some point we are at the top of our learning curve and we then figure out that, hey, probably something is wrong. So we start to simplify our code. So again, at some point we are writing a very simple code. Of course, the simple code that we started in the beginning of our career is completely different from the simple code that I mean when we are experienced developers, experienced architects. But the simple code means that we are able to support the growth of our application, the maintenance of it, plus simplicity, and at some point as well complexity. But okay, probably you can imagine how the simple code looks like, but how the simple architecture will look like. Because here we are today just to focus on the evolutionary architecture approach. And before we start to talk about the evolution of our architecture, I would like first to introduce some kind of a definition of software architecture. But the problem is that each software architect will have a completely different definition because there is nothing like official statement of what software architecture is. In my case, I always divide it into the 7 steps of software architecture. First step is to handle business analysis. How do we do that is a topic for another episode, but here I am talking about the workshops with stakeholders, customers, domain experts, developers, and so on, to just have a clear understanding of our business domain. And as business domain here, I mean here like e-commerce, shop, after sales desk, banking system, file management system, fitness studio system, and so on. So there are so many different business domains that we are operating on a daily basis that it would be hard to tell you about all the possibilities that are there. Second step is that after we have this analysis and the big picture overview of our system, then we try to start to divide it into parts based on the processes that we have there. So each business domain, big one, contains multiple processes, hundreds, thousands of different processes. And now we need to take these processes and combine them somehow into the groups of responsibility, the boundaries. And to do that, we are splitting our business domain into smaller subdomains. And then we can combine the subdomains into boundaries. Such boundary can contain one or many subdomains. Number 3 is the infrastructure itself. So do we go cloud agnostic approach, or maybe we are tightly coupled, and that's fine, to one of the cloud providers? What kind of monitoring solution do we need? What kind of logging solution do we need? Do we need API gateway? Do we need load balancer? Do we need cache? And so on. And this is the part where we need to answer our questions of how we want to support our business domain from the previous 2 steps with the infrastructure. To decide on infrastructure, you quite often need as well to know how many users are in the application, how many daily active users are there, how many requests per second can we expect, and so on. So here we are collecting all the numbers, and based on numbers we can decide on our infrastructure. Then we need to define in number 4 the deployment strategy. Do we need to go with microservices, or we want to go with modular monolith, or maybe we want just to combine our modular monolith with some microservices, or we just start with a simple monolith and then we will see what happens next. And that's the step number 4. Number 5 is to select patterns, correct architectural patterns, logical patterns, and so on. Here we can understand it as active record, transaction script, service layer, or domain model, and so on. Number 6 of our software architecture is test strategy. What areas do we want to automate? Do we want to automate all the areas? Do we want to go with the pyramid of tests, inverse pyramid of tests? Or do we want to have the same level of tests for unit tests, integration tests, and end-to-end tests? This is something which is super important while building application, because it will simplify your maintenance in the next months. And the last part is a release strategy. How do we want to release our application? And it can be completely different based on organization in which you are working, based on the size of the company, based on the size of application, and so on and so on. In the best case scenario, you will be having just continuous deployment. So your every single commit will go into the production, and you will be safe because of this automation that you did with your testing strategy, with your pair programming while working on something. You might do as well other things which are related here, and which will allow you to continuously deploy application. But sometimes there might be some guy who needs to click the button, so you are degrading your continuous deployments to continuous delivery, that at any point in time you are able to release your software, but someone always have to approve it. Or maybe it's not possible in your organization because of political reasons, and then you need to have, like in old days, UAT environment where testers will go and try to test your features, and then you will deploy it, and you are deploying it, let's say, once per month with set of features that are coming, for example, from the release train. And these are all these pillars, steps of my understanding of software architecture. As you can see, it might be really complex. So for sure, it's not enough to just have one software architect who are deciding about everything, like in the past, a software architect that is sitting in ivory tower. We are not talking here about some kind of a guy like that, but here it would require entire team thinking about this software architecture and making the decisions together. Still, it will be very complex, especially in the beginning of the product or project that you are doing. In general, while starting something new, something fresh, and you don't know this business domain in which you operate, you don't know the circumstances, you don't know the numbers and so on, you have so many decisions to make when your level of knowledge is so small, so low. And here, when we are deciding in the beginning for as many components as possible, we are falling into the problem of the future where we won't be able to maintain it anymore. So it would make way more sense that when we have a limited knowledge, we are as well applying limited components. And this leads to the simple architecture that you are going to provide, because the less components you have, the easier software architecture you will have. And then within time, when you gain the knowledge of your business domain, you will be able to apply way wiser decisions on what you want to include in your application. And this will be based on your current needs and not wishful thinking. This kind of issues are falling into the definition of something called project paradox. But it doesn't mean that it's just for a project. It applies as well to products that you are building. So it's your project/product thinking. However, still, you can fall in a trap. Even if you limit the decisions that you make in the beginning, you can still fall into the trap of something which is called too trivial software architecture. It happens quite often that we are starting with a simple monolith, and within time we are adding new features and new features and new features and so on. At some point it grows to some kind of a monster which is then eating the spaghetti code, and we are operating all in a big ball of mud. We were adding these features really fast. We didn't think about the structure of our solution and so on. And everything is referencing everything. You have dependencies between different areas of your application, and it will lead at some point to a legacy app, and you will need to start thinking about refactoring. So it's very important that when you are starting in a simple manner, you need to think about tomorrow. How do you want to add this new feature? If it is required to add a new area in your app, new module and so on. This way you can build some kind of a modularized monolith, and afterwards, if you need to scale more and more and more, you can even extract parts of this modular monolith, so concrete modules, to microservices, and you will have a combination, a hybrid approach about application. And here your application will be healthy, quite healthy. On the other hand, when you are building something new and you make a lot of different decisions for components, libraries, frameworks, and so on, you might find your architecture at some point too complex to operate. And here by too complex to operate, we are talking about this entry threshold, which is very high, And the complexity of the solution is not meeting the needs of your app, because your app would require way less components, way less libraries, and way less complexity. As you can see here, when talking about this too trivial architecture for too long, and the case where you can just start in a simple way and then evolve it slowly to something completely different that is maintainable, that supports growth, scalability, and complexity within time, we are talking about the evolution. And here it will be called evolutionary architecture. Evolutionary architecture, in my understanding, is based on 4 steps of evolution. First is that we are focusing on simplicity. Imagine that you are joining a startup, you are building a greenfield application. You can base it completely on a no-code or low-code solutions, but if you decide for a coding solution, you can start just with a single assembly with your production code. And then inside you will be able to gather all these features that you have and serve the customer needs to validate with your MVP after this 3 or 4 weeks that this product that you are building makes sense and it is usable for customers. The second step of evolution is to focus on maintainability, because at some point in your application it will be hard to maintain it while having just one single assembly. So now it might make sense to extract part of the code into the separate assembly. And if you do wisely the first step with simplicity and you divide the areas of your application. You remember when I was talking about the business domain and splitting it to the subdomains, multiple subdomains, and setting up boundaries around it. Inside this boundary, we can just grab everything what is there and take it out to a separate assembly, and our module will be already in a separate assembly, while other modules will be still in this first one. Then if we observe that our application is growing more and more and more, we can take other modules and put them in a separate assemblies, and so on. This way we are building maintainable code. Step number 3 of evolutionary approach is to focus on growth. At some point it would be very hard, or maybe not hard, but it will cost a lot to scale entire application as a single deployment unit. Imagine your modular monolith that you have, and each time you need to scale, you scale all the areas, entire modular monolith, and you might have 10 instances of this modular monolith. It will require a lot of resources, time needed to scale, and so on. So might make sense at some point that part of your modules that are quite often changed, that are needing for a large scale, so a lot of people are using this module on a daily basis and so on, to grab this one module and extract it to a microservice. So now you will have, in this step number 3 of a growth, you will have a hybrid approach, combination between modular monolith and microservices. But there is a trade-off, because now you need some kind of a component for communication between your modular monolith and microservice, or microservices if you have more. And additionally, you have problems with network, so latency, failures, and so on and so on. This is something that you need to think of. So as you can see, each step will come with some trade-offs. Number 4 is to focus on complexity. At some point, some of your modules or microservices that are representing this module will need to handle complex business rules, and this is the time where you might think about changing what you have in this module to something that can help you with complexity. And here the first thing that you can think of is domain model and this tactical domain-driven design that you have probably heard of, where you can divide the pieces of your code into entities, value objects, aggregates, and so on. And for example, aggregate will help you to make sure that your data stay consistent. You can treat it then as a guardian of consistency. And then if the next module gets more and more complex, you can evolve into the direction of a domain model and so on and so on. So this is like step-by-step approach for the architecture to evolve over time. Okay, but what are the details of each step? How to handle the logic in each step? How to handle your software architecture? This is something that I would like to share with you in the series of episodes around evolutionary architecture. Today it was the first episode where you were able to learn about the overview of how do I build successful apps that stay on track for many years. In the next episode, we will focus on the simplicity, so the step number 1 of evolutionary architecture, and there I will show you what does the simplicity mean, because there is no one single rule, a silver bullet solution that will work for each case. It might be based on some virtual machine, it might be based on some services like app services in Azure or Azure Container Apps, or anything else that you can think of, and I will share you how to decide and when to decide for what based on the requirements that you have. Don't miss the next episode, it will be released next Tuesday. Thanks for watching and let me know in comments what do you think about such approach of evolution of your architecture. Do you like it? If yes, then thumbs up, if no, thumbs down, of course. And if you are interested in how it works and you want to be up in front of others while not waiting for this next episodes, I invite you to check out the GitHub repository that we created together with my colleague Kamil in the last year. And there you can see how this evolutionary architecture is approached from the perspective of .NET and C#. Thanks a lot and wish you a great pleasure while watching the episode. See ya!